Hi, my name is Jennifer Davis. I have been working in industry for 20 years. And in that time, I have had a lot of time to experience building highly reliable, redundant systems. I have tried to I have written a book with Ren Daniels called Effective DevOps to sort of encapsulate a lot of the practices I've seen that are helpful in building teams and do the DevOps the way that I define DevOps, which is working together with multiple different teams, building value with understanding that it needs to be sustainable and repeatable. I'm currently working on a new book called Modern System Administration, and it's a little different from the SRE book, and that I'm trying to reach all of the folks that are doing ops in whatever format that is now and give them sort of a path to follow, because I think a lot of times we don't think about state transitions. We start in one state, we get to the next state, and we expect everyone just flip on over. That's not super helpful. So if you are in a system administration sort of mindset, or you know what it's like and you want to help contribute your story, I would love to hear those stories. Today, I want to focus on a topic that is the foundation of everything in our society, whether it's from between the individuals working together on a team, or all the teams within an organization doing the DevOps, or our customers and our users. One of the things I heard recently when I was broaching this topic was someone asked me, how do I get my users to stop doing stupid stuff? Why are they such idiots? And I realized, there's this fundamental problem in our industry where we create the systems that are complex, and we create these trust situations where we allow people to think that something behaves a certain way, and yet there's endemic problems with the system. I don't see us talking about this, and it's really challenging. I want us to stop talking about how stupid our users are, our customers, and start talking about, here is this resource that is underutilized, undervalued. We build trust with our customers. We build trust between each other as we're building stuff, and this is a value. It's not something that I can buy. It's not something I can trade for. I have to earn it. And there's a number of different ways we can think about and talk about trust. I am not going to talk about the ethical considerations we need to think about, or talk about the ways that we work in teams and how we build trust. All of these things are super complex. What I am going to talk about is how we think about the trust that people put in us by giving us their data. And sometimes it's data that we haven't even thought about the value of. This is when we reveal personal identifying information or allow malicious activity to happen on people's accounts, their bank accounts, we're violating their trust. And it's very hard to recover this. It's really easy when we think about this to postpone security, which is one of the ways that we can enable or prevent these kind of activities from happening. It's easy to wait to do it last. I mean, that's the way our systems have worked in the software development lifecycle. It's like throw it over the wall, and then security identifies problems after the fact. And sometimes the architecture and deciding on what framework to use, we're thinking about what the code looks like, how easy it is to use, and not how it responds when the hackers actually show up. And they're going to show up. Security concerns are happening all the time. If you have never checked out the Have I Been Pwned site, it's very useful to put your little email address in there and see how many vulnerabilities have been exposed, how many particular companies have released identifying information. And you might think, well, it's not too bad. It's only this kind of information, but the attackers are getting much smarter and working harder in building these systems that aggregate vulnerabilities across different systems. We need to work better and smarter in the ways that we protect this. So I get it. I'm human, you're human, we're gonna make mistakes, and it's easy to put off the things that are big items until we can actually, like things that we can think about, we can put off the big things for the small things. So everyone's gonna be impacted by climate change, and yet we're still debating about what particular actions we're gonna take. And sometimes, maybe the things that we need to focus on are the most important. And maybe security isn't the first thing, but we can do more than what we are doing now. Security incidents are a matter of when, not if. The risks can be physical in nature. They can be via our network, our infrastructure. They can be lack of compliance or within our applications themselves. So how do we leverage some of the security practices out there and actually implement them into our workflow? Well, just like anything else in our environments where it's a big, giant problem, let's take it and break it up into smaller pieces. So I'm gonna talk about continuous security and applying the security mindset, set of tools and practices across the lifecycle. Now, I'm not gonna cover everything, just little pieces within effective tools that you can use across each of these parts in this life cycle. First, what I'm gonna talk about is establish kind of the common context. What do we mean by security? How many folks actually do security right now? How many people don't do security? This is a very fascinating thing, and the reason I wanted to talk about this. The second thing I'm gonna do is talk about some of the foundation elements, tools and practices you can apply in your environment right now, and then talk a little bit about advancing principles. So, there's a lot more than what I could actually cover. A proper security training would be days, weeks, to give you a broad landscape of what is available to you. But my goal here is to enable each and every one of you to get something from this. If you're a practice security engineer, maybe you'll find some strategies to help bring this into your environments where you're having challenges engaging folks to adopt security practices. If you're new, you'll have a little bit more of a grounding to understand where to go next. So, core to security is the CIA triad. Often this is discussed, and we think about availability as a primary concept that SREs need to worry about. But this is not just the only area where this information overlaps. So when we talk about confidentiality, we're specifically talking about who has access to the specific data and when they have access to it. We want to make sure that only the right people have access to data. So no one should have access to my bank account information unless they should have access to it. Integrity is about the data being correct and also that only the people who should be able to modify it are able to modify it. And then availability, of course, is the system available, but also is it available when I need it? So it's not good enough to just be like, hey, it's 99.9% available. Well, if I only need it one time of day and it's not available then, it's not available. So like, it's hard to measure that. Another thing to think about when we're talking about security is there's kind of two security defects. There's the bugs, which is where we've implemented something and maybe we've made a mistake in that implementation. Sort of like Heartbleed is an example of this. And that people can take advantage of this vulnerability and it's a problem. A deeper, harder problem to detect are security flaws. And that's where it's implemented exactly the way we meant it to be implemented, but there's actually use cases where it causes problems. Sometimes this is where you see long-standing operating system design flaws, where it's flagged as in Red Hat or whatever, is like, this is a flaw. Well, it's because it's how it was implemented. And The problem is, so many things then get built on top of this. Changing that implementation is super costly. So let's shift our focus a little and talk about, why do people hack? Well, a lot of times, when I've been in my ops roles, there's this focus on the malicious attacker who is inside the building. And everyone wants to put in all these security controls, and that is a great thing, but it also makes it harder to work or recognize when they're a problem. But the actual number one motivation of attackers, as identified by a Verizon report where they did analysis of a number of attacks, is it's financial gain, people wanting to make money. If you look at that Have I Been Pwned site, it literally shows where the information is being sold on the dark web. So these are external attackers coming in. The second level is espionage and strategic gain, so like state actors attacking. Those happen quite frequently as well. Maybe not as well known here in Europe, but definitely it's a big concern in the US with the elections coming up, as well as in Australia, there it was discovered that there was a security breach. And then finally, there's the people who do it for fun, and maybe they have ideology concerns, or they have a grudge against their employer. All of these things matter. Now, another side of this is that sometimes we have to think about, what is the data that we have? Not just what we know we have, but information that we're gathering. One of the number one things when I go into a customer or I talk to people about the design of their application, they're thinking about the functionality of the application. What is that they are building? And then I ask them a simple question. What's the value in your data? And this is a really hard question. People don't have ready-made answers for this. And it's very hard, because if you don't understand what the value of your data is, even before you start engineering where it is going to lay on the system and how it's going to work and how it's going to be available, if you don't know the value, you don't really understand why people might be hacking you from that perspective. If you have personally identifying information, if you have credit card information, there's also compliance rules that govern some of these types of data. And so also your leadership may be vulnerable to particular fines depending on the country. But all of this magnifies what the impact is of your system. So we talked about the basics. Let's start building up some of the core foundations of what it means to do security across the different parts of our life cycle. It's impossible to release perfectly secure software. It's just like thinking about our error budgets and our availability and how much makes sense. When people try to sell me secure software, I feel like they don't understand what they're saying. There is no such thing as secure software. There's just software that we haven't identified problems yet. So what do we do? We need to think about designing for defense in depth, meaning we're not going to do the Swiss cheese and align holes. We're going to think about how to build our architecture and think about what pieces we can defend throughout the layers of our systems that we're building. So how many people use open source? How many people scan their open source for security issues? How many people don't? You should never assume that the stuff you're pulling off from the internet is actually okay. One of the things that came up in this report is that if we look at the data that people are reporting, is that one, there's security vulnerabilities, and two, that open source developers don't always know the common security practices. So if you aren't contributing to open source now, this is a great place to get started, helping projects become more secure. And then three, nobody's actually checking this and making sure that it's in a good state. So one step in thinking about defense in depth is thinking about, how do I secure software that I pull from the internet? What are the steps that I need to take? Patch your images, build your images from your known practices so you have good images to start from. So if I think about going back to my software development lifecycle and I think about, okay, like at the beginning, when I'm designing my application, I'm thinking about what it is that I'm building and how I'm building it. I need to put on the CIA hat. I need to think about what are my security concerns. So what does that look like? Well, instead of doing that given when then and sort of framing it that way, thinking about what can a user see? What can they do when they log into a site? What information am I logging? Where am I logging it? What am I doing with those logs? And how do I approach failed logins? If there's 5 failed logins in a row, do I assume the person is a malicious attacker and like block them? Or could it be that maybe I have a problem on my site and the password that I allow people to set is 16 characters, but then I only allow them to put in 10? And identifying these kind of issues, and in that process, as I'm talking through it, figuring out the flow of what a security story looks like. So even if I don't follow some prescriptive Agile or Scrum process of documenting all of the things, I need to have a way of inputting security stories into my workflow so that it shows when it's done. So then this also helps when we have an incident because then we're able to flag, oh, this is a security story and it has this kind of prioritization. The OWASP Foundation provides a number of free software security tools and practices, and the Application Security Verification Standard Project is one of them. And it'll help guide you in terms of thinking, if you've never done it before, about stories you need to think about when it comes to security concerns. Earlier, I talked about, let's think about what the hackers are doing. Well, it's actually a practice that you can adopt, which is the threat modeling, which we think about what it is that they're trying to attack and why. And we have to think about all of the assets we have. Sometimes people think, oh, I don't have assets now, I'm using the cloud. Well, you do. You have your data, you have your endpoints. All of these things you have to think about and worry who has access and why and what might they try and do. And this is a really good process of thinking through at the early stages of design. The earlier you find problems, the easier and cheaper they are to fix. One of the things that is not interesting to me is when people talk to me about vendor lock-in and the cost of particular services. What I am interested in talking about is the architectural trade-offs that we are intentionally making or should be intentionally making and talking about with regards to services in the cloud or that we home grow. And what I mean by that is, depending on the platform, you're getting a number of operational considerations taken care of for you. And that includes some amount of security. So for example, you can deploy a managed Azure MySQL instance, and it's gonna have encryption, encrypted endpoints, encrypted data. Just about everything is encrypted, and it's gonna follow some number of compliance protocols. The thing about it is, you can also deploy your own instance, install MySQL, do all of the customizations, and that's great. And I'm not saying one way or the other is right or wrong, but what is interesting is not the cost, other than saying, like, explicitly, maybe you have really awesome people on staff that are doing all the security hardening, and maybe you're underpaying them if the price of a hosted service where you're getting all of that for free or embedded as part of the product is cheaper than you having that in-house experience. No matter what my service is, there is some, whether I'm spending money on infrastructure as a service, platform as a service, software as a service, serverless, whatever the case is, no provider is going to be providing you 100% security. There is no way to do that. Now, there is this shared security model where a cloud provider is providing some element of security. If we look at this sort of matrix, it shows you that. And the thing about this is, I keep saying it, but data, who has access to it and why, and those endpoints, you are the only one with the context to understand the value of your application. I can't tell you how to lock down your application until you tell me what the value is that you're building and who should have access. So it's really critical. Yes, we're shifting some of our security concerns, and that's expensive at the cost like we reduce our operational burden. Another practice is testing code. And by that, I mean your infrastructure code, your development code, any scripts you're writing, you should test them. One of the interesting things that have come out of GitHub recently is the ability for it to surface dependencies that have vulnerabilities. But that's not gonna cover the examples where you have problems. And so one of the first things you can do is lint your code. In the last few months, I keep asking folks, do you lint your code? And many people have said, what is linting? Or they've said, that's stylistic stuff, I don't care about that, like I don't really care about bike shedding. But if you think about it, reducing bike shedding is super fantastic. If everyone's encoding what they want out of the code and it's easy to debug at the point when you have an incident, that's of value. We also find flaws in our code if we lint. This iOS bug, if you can't see it, but there's 2 go-to fails in a row. If they just adopted a linting strategy, they would have caught this well before it released. And linting can be embedded in your code editor and automatically happen. And so the fast feedback that we want out of building our systems and our infrastructure is right there. So a super quick win, lint your code. To ease the problems that might come out of the overload of like if you type the linting command and it reports a bunch of errors, is you can customize just about any linter with what concerns you have. And so this can be a per project, per environment, and so then everyone can have the same standards, and you can adopt it as you want, rather than everyone all of a sudden complaining, I'm getting 500 errors with linting, and I just can't care about that. Another important practice is secure code reviews. And by that I mean someone taking on the perspective of security. Tagging any code changes that have to do with security with a flag to say this is a security issue that we considered CIA principles in this code that we wrote. This is really critical because when I want to figure out what happens if we find a flaw, especially the ones that are super problematic, I want to know, what did we think about? Why did we make these decisions? Because the fact is, we're all human. It's okay to make mistakes. It's not losing that information and knowledge that we built over time is super critical. Issues are going to happen. So instead of waiting for it to happen and then responding, we need a plan for these escalations. We need to be able to identify, assess, and remediate them. My coworker, Jason Hand, has this great presentation where he talks about building out your minimum viable response plan. So it's like the absolute minimum you need in your environment. But security concerns and security incidents are a bit different from other incident types. One, the problem might happen and nobody knows about it for months. So how do you deal with a problem that has existed for months? Maybe you've even lost a good source of data, or it's not backed up to tape, or whatever the case is. You don't have good logging. So how do you handle that? How do you handle informing your customers in a healthy way that maintains their trust? A second problem that comes up with security incidents are that sometimes there's no impact. With Heartbleed, we all saw the problem and everyone in operations jumped on it to upgrade it because we knew the impact. So even though there's zero impact, we have to plan for these things and execute them. Every platform is going to have a different set of services that it provides you and a different set of limitations. I don't know how many times I've run into systems where I'm building something and something happens and it's like, oh, what can we do here? I joined Azure last year, and one of the things I found super fascinating was this free tool that's available for everyone. You can upgrade it, but the thing that was fascinating to me was that when I talked to people, not many people knew about it. And it was interesting because I could see, like, it was a great visualization. I know, like, the single pane of glass is not a useful concept, but I could see really quickly what was a problem. Click on the problems, like the red ones, and find, oh, where are these really serious vulnerabilities that we should patch now? And so it's super fascinating. If you use Azure, I totally recommend go check out the free option that just will tell you, hey, your versions are out of date, or you have a activity that doesn't look normal. So I've talked about different strategies and foundational practices you can adopt at different parts of your life cycle. At a minimum, take the feedback that you discover and incorporate it back into your pipelines so that you can get regression testing and identify that problems aren't going to repeat themselves. Let's talk about some of the more advanced principles. If you're doing all of these other things, there are additional steps that you can take. Once you have a solid security program, bug bounty programs are kind of interesting. I don't recommend this as a way to spend money at the start because they can be very expensive, but they're very useful in that you're engaging with a community of research scientists and other folks, and you're describing the set of resources you want people to access or try to access and ways that they can access it, like acceptable means, and how much you're going to pay them to do it. Another great resource is for individual leveling up of skills, because we all should be doing security, is doing capture the flag events. There's a great one that was just recently, the CTF with Google. There's actually a resource for my non-binary folks and women. We have a community where we talk about CTF programs and work together on them and have resources, so that's also an option. Capture the flag is basically, it will make you a paranoid person about your application if you aren't already paranoid, because you'll see how much information can be discovered in the various ways that we're vulnerable. Another advanced exercise is a red team exercise, and this can be implemented in various ways, but the idea is that you've got attackers that are internal to your company. If you do not have an incident response plan or your incident team is not skilled enough, this is not a practice to implement. If you know there's problems, all you're gonna do is uncover the way that you have problems in your environment. These are usually exercising some of the aspects in your environment where it's like, how are you gonna respond if you have a hacking event? So what do you do next? Well, identify your security maturity. Where are you? Are you doing security practices? Maybe through this talk, you've discovered, hey, I'm actually doing some security now. I didn't even know it. And that's awesome. Assess where the valuable practices that you can adopt are. Some of these might be useful right now, some less so. Encourage everyone to learn security skills. This is not something where we should be saying, let's pass it over the wall to the security engineers. And then take all of that information that you're getting across all of the different parts of your application's lifecycle and service life cycles to feed that information back in to your development. A key part of this that we don't often talk about is feeding it back to our third-party services that we use. If you discover a problem, or you identify issues where, hey, this is a problem, talk to those companies. There's a number of companies that I've discovered problems with where it's basically talk to them about, hey, the way that this works is actually exposing problematic data. Then keep updating your threat models. As you're progressing, creating new features, developing new software, your models are going to change. Who is going to be trying to hack you? Who's trying to take your information? Who's trying to get into and modify information? It's going to change as you become more popular, as you create new data, and recognize the value that people are finding in aggregate information. Stuff they can get from you combined with stuff from other companies. Let's stop thinking about security as some kind of in conflict with features. It's not helpful. It's not just about spending money on security practices. It's about building our customers' trust. So continuous security is achievable through regular iterative processes that we all can adopt. I want to thank everyone for participating in this awesome talk. Thank you so much. You can reach me by email, Jennifer@modernoperations.org, or on Twitter @SIGJE.
So we have time for some questions. If you'd like to ask one, please use the microphone. And I actually do have one to start.
Okay, so the rules of the questions is that you have to sing it.
I do not have a question.
Oh, no, come on, you can do this. I'll help you.
I'm going to respectfully pass on the singing for all of your sake, not just mine. So the CIA triad is really interesting. And I hadn't really thought about this before, but I suspect you can trade off one for the other in some instances. But like during a security incident, do you have a way of thinking about like screw availability, lock things down? Like how would you, if you had to prioritize them, is there a way to think about it like that?
I think it depends on what the specific data is. There are instances where you definitely want to shut down whatever it is happening. Other times you want to get, like if you've detected it early enough, you want to actually discover what they were trying to do, and you don't want them to find out. So this is one of those interesting places where I kind of wonder about our compliance laws and how we implement this stuff. It doesn't sometimes give us the opportunity to not reveal that we know that a problem's occurring.
Okay, thank you very much.
Anybody else have questions, comments, thoughts, feedback?
I'm also gonna pass on the singing. Yeah, so how do you convince maybe your management that it's a good idea to work on security before it's too late, before something bad happens? And yeah, let's start with that.
Again, it depends on your context and what kind of environment you are in. Number one, does your management trust you? Number two, are you able to convey it in a way that is to their gain? So this is one of the reasons I spent a lot of time thinking about, like, what is it that we are building that's different than money, right? Because spending money on something that's not developing a feature when people don't imagine reliability, availability, security as features, that just looks like a cost. So what is it that we're building? We're building trust. So framing it in that way can be very useful.
Another way I would suggest is just to tell them, if you don't have that layer of security, how much it could cost them. That's another way. You just put them on the other side. You say, well, if this happens, you just disappear because, for example, GDPR, we have a lot of companies that are not full compliant, and one small thing may just break the whole company. So telling them how much they would need to pay would be a good idea.
I would shift it a little bit, like, because when you get into a mode of operating from fear, which is what we do, we totally want people to be informed. And yeah, there's some serious concerns and in some cases jail time But like framing it in terms of defense in depth, like here's the value that we get out of doing this practice. Here's the value we get out of this practice.
There was a question over here.
Hi. Linting is awesome. How do you persuade more people to do it? And once they've started, do they like it?
I love you in the best possible way. Linting is absolutely fabulous, and when it is approached from not as a prescriptive practice that you must do this, kind of like what people fall into with Agile, and there's a reason I didn't put linting, and instead I said static code analysis, because it doesn't have the feels. So you can say things, so like don't name, if you are developing a tool, don't call it the linter, like call it something else, and then just enable it as a practice. And it does magic. Is that helpful? I didn't sing it, I'm sorry. I didn't say I was gonna sing answers. Anybody else? How many people are gonna go back to their environment and adopt some security? Including what you're already doing. Raise your hands high, like let's be proud. We are all part of our security revolution. Okay.
I have a question.
Oh, we're
Right here. Here, hi.
Oh, hi.
Just a question about threat models. I was wondering if you have any examples of resources or specific kind of rules on how to probe and get the actual visualization of your systems overall and like the level of security you're actually employing.
There are a few available out there. Microsoft is actually one of the first people or first companies to release a threat model that people could adopt. OWASP, which I mentioned earlier, like if you have free time, OWASP is a magical place of security to plug into your brain. And they have a modeler.
Thanks.
I think we have time for one more question, if there is one. Okay, let's thank the speaker.